Next, we welcome longtime advocate for ecological farming systems, Dr. Charles Murfield, or Murph. Murph has over 3 decades of experience in organic horticulture and agroecology. He leads the BHU Future Farming Center, the only research hub in New Zealand focused specifically on agroecological science and extension. From non-chemical weed management to nutrient strategies that honor soil life, Murph has been a leading voice in the shift towards systems thinking and low-input solutions. Today, he'll share a vision for the future of weeding, tillage, and fertilizers, one rooted in both evidence and ethics. Please join me in welcoming Murph.
Tēnā koutou, tēnā koutou, tēnā koutou katoa. Ko Thames te awa, ko Box Hill te moanga, ko Lincoln te anga, ko Murph taka ingoa. Thank you very much for that introduction, and thank you very much for the organising committee for inviting me back again to speak at the Organic and Biodynamic Wine Conference. Let's go. Right, quick roadmap, why we're in so much doo-doo, why soil is the foundation of everything. I'm going to have another rant about cultivation and weed management. And indeed, I think this presentation, it's interesting. This is we're all seemingly increasingly on the same page, the same hymn sheet in this space. So I'm going to cover a lot of ground that's already been covered, but I'm hoping to give you a different perspective and some different depths on what we've been talking about so far. Why I think ecological weed management's the future, and I've come out of organic vegetable production, so I'm a complete machinery head. So we are going to briefly touch on electrical weed control before we touch on nutrients. So this is a bit of a smorgasbord. Right, we are in an increasingly rapidly changing environment. And this talk is not just about organics. This increasingly applies to conventional production as well. And I have to say, I'm completely bemused by this "we need to save the planet" rubbish. It's not. Can we just call a spade here? We need to stop destroying our planetary life support systems that keep us alive. We need to say what's actually going on here, not some euphemistic rubbish about saving planets. Sorry. Conventional systems are under increasing pressure. I spend most of my time working now with the conventional guys, having spent 35 plus years in organics, because they are becoming essentially like organics, like sustainable, like regenerative / agroecology. Nobody's talking at their field days about more fertilizers and pesticides now, they're all talking about less stuff. That's all feeding through to our citizens, who are causing our politicians to shift their positions, so we're seeing increasing legislation. But increasingly in that conventional space, their customers are going, jump. And as Kiwis, we just go, how high? I'm seeing conventional producers poster child to chemical agriculture, moving to mechanical weeding because their customers are telling them that's the only option. So this is all about organics and conventional production in equal parts. So where does all this start? You've heard this before, soil. We've known about the importance of soil since the dawn of civilization. James Milton, we're not standing on dirt but on the top of another kingdom. We've known about this stuff for a very long time, but we've failed to implement it. Recent big old scientific study, 60%, just shy of, all living things, including everything that lives in the ocean, make soil its home. Soil is the most important ecosystem, the most biodiverse ecosystem on the planet. And here in New Zealand, we're worried about trees and birds. No, sorry, it's the soil that's the most important biodiversity here. Soil is literally the progeny, the child of the climate and the rocks. It's at the heart of all our planetary systems that keep us alive. It's at the heart of the carbon cycle, the water cycle flows through it. It's key in the nitrogen cycle. As that paper pointed out, it's the foundation for virtually all living things on Earth, and we continue to treat it like dirt, not like the most important ecosystem on the planet. So we have to do better. And ironically for me, organic agriculture, founded a century ago on the very fundamental issue of the health of soil, and we seem to have forgotten about that in modern organics. We prattle on about pesticides and soluble fertilizers. There's nothing in current standards that really mandates the health of soil. It's really interesting to me, we had the conversations yesterday about Rodale's regenerative organic standards. For me, that just fills three massive holes in current standards: animal welfare, worker welfare, and soil health. And I'm kind of going, why did soil health have to be fixed in standards when it's what our movement was founded on? Unbelievable. IFOAM's first principle and the organic mantra. Why aren't we implementing this stuff? It's also the foundation of terroir. Soil, weather, and whatever grapes you've planted are your terroir. Sadly, we can't control the weather. We've got quite a lot of control over what you do to your soil. So, what are the key levers in terms of managing your soil for improving its health? Well, kind of astonishingly, we've had a proper old scientific revolution, a paradigm shift, toys out of cot stuff, in terms of how soil organic matter is formed and what drives soil health. So this is the old paradigm. This is what we used to think. Stuff dies, leaves fall on ground, we shovel compost onto the ground, small organisms break it down, the microbes hook into it and break it down to the point that it is mineralized into inorganic compounds which plants can take up again. We used to think that the simple compounds, the sugars, the proteins, the oils, the fats, decomposed really quickly. The more complex stuff, the polymers, like cellulose, took weeks to years to decompose. And then the really tough stuff, the woody lignified material, took centuries to millennia and became humus. And humus here I'm using in the technical meaning. Is defined as organic matter that is recalcitrant. It resists decay. And everybody is rapidly rewriting their textbooks. So this is the new paradigm. Now, the old paradigm clearly can't be wrong because clearly dead stuff ends up on soil. Little critters do clearly chew into it, and the microbes decompose it. This is now described as POM, particulate organic matter. We used to think this was the whole story. This is now only 20% of the story. Only 20% of organic matter is POM. And it doesn't last centuries to millennia. Even the tough woody stuff decomposes within a few years to a few centuries. And somewhat shockingly, for us in organics, humus, in terms of this recalcitrant organic matter, does not exist. Repeat, humus does not exist. Indeed, it doesn't actually make sense. We start with big old chunks of organic matter that are broken down and down and down into smaller and smaller components, all the way down back to inorganic compounds, and somewhere along this getting smaller path, poof, this great big old humus molecule appears. And what is it about the arrangement of the carbon, oxygen, hydrogen, and NPK in this thing that makes it resist decay compared to all the other carbon, oxygen, hydrogen stuff in the soil that decomposes really happily? When we look at soil now with our whizzy new soil science stuff, like intense light beams, humus is not there. It's missing in action. It's AWOL. It is an artifact of the alkali extraction method of the last century. The new stuff's over here on the right. Plants put out through their roots between 10 to 40% of the photosynthetes they make from sunlight as root exudates. And these are the simple compounds, soluble compounds, the sugars, the fats, the lipids that we think decomposed really quickly and were irrelevant. These are feeding a vast density and diversity of microbes living directly around the plant roots. The microbes return the favor by providing the plant with water, nutrients, protection from pests and pathogens. Different plants produce different exudates that feed different microbes. Plants can even change the exudates they make to feed particular microbes when they need their specific help. This is the heart of what's going on in terms of this change of understanding. To achieve a diversity of soil biology, we need a diversity of plants producing as much exudates as possible. So the microbes consume those exudates. The microbes that consume themselves, the energy, the nutrients contained in those exudates churn through the soil ecosystem, and they end up as tiny, tiny little pieces of organic matter inside cracks inside soil minerals, particularly inside the platelets of clays. And this stuff is called mineral-associated organic matter, which must have one of the most hideous acronyms ever invented. MAOM or MAOM, we don't even know how to pronounce this wretched acronym. But it's really important because 80% of organic matter in soil is in the form of MAOM. And this is the stuff that lasts for centuries to millennia, not because it's some weirdo, impossible way recalcitrant, resists decay, because it's in such a small hole that even the bacteria can't get at it. So we've been thinking about plants completely the wrong way. High school science, plants take up water and nutrients from their roots, they push it up and they grow foliage. Well, that's back to front actually. Plants take sunlight, the energy from sunlight, they are heterotrophs, they are the primary producers, the foundation of ecosystems, and they suck carbon dioxide out of the air because virtually all forms of carbon are insoluble apart from a few sugars, so they can't take up carbon via their roots. They have to take it up via the atmosphere. And plants are 45% carbon. They're nearly half carbon. And then they're nearly half oxygen as well, with some hydrogen in there. 96% carbon, oxygen, and hydrogen. The NPK is that 4% that's left over. So plants are basically built of the atmosphere, not built from soil. Then they combine that carbon, oxygen, and hydrogen from the atmosphere and that energy from sunlight, turn it into simple, soluble compounds, the root exudates, and pump it out into the soil to drive the soil ecosystem. So the primary source of energy and nutrients for the soil ecosystem is plant root exudates. It's not all that compost and stuff we've been prattling on about for a century. Sorry. So the answer is a diversity of living plant roots year-round. If you're kind of going, I've heard that somewhere before, it's because the regen guys bang on about this never-ending, because they're completely focused on soil health, as organics was at its foundation, and they've been fed this new science as it has evolved. So they've had a hotline to what's been going on. So, what's weeding got to do all with this? Well, I wrote this chapter for an encyclopedia of soil with old Trevor James, another New Zealand weed scientist. And I have to say, I look at weed management, both chemical and physical, and there's an awful lot of prattling on and complete nonsense in this space about how these things negatively impact soil health. The largest negative impact of both chemical and mechanical weeding on soil health is because they reduce the diversity and biomass of plants, which is their primary objective. It's the complete opposite of living plant roots year-round. I've spent 20 years at the start of my career perfecting mechanical weed control in organic vegetables. I got really good at it. I could grow you 100 hectares of organic vegetables and there will be nothing but the vegetable plants we planted and bare soil. And I look at that now and go, what a colossal disaster. Removing, not having that plant diversity, lacking that living green cover amongst those vegetables is what's killing that soil. Mechanical weeding is not cool. It also loosens the soil surface. At a planetary level, the use of herbicides, completely agree with Andre yesterday, in terms of the planetary boundaries, novel entities, all the synthetic chemicals, the pesticides, the plastic we're putting into the environment are the biggest risks to human existence we have. But at the individual vineyard level, all that cultivation and all that loose soil is a massive risk of erosion. Soil is basically your capital asset. Everything else on a vineyard, a farm is ephemeral. And if it ends up in the waterway, not only have you lost your capital asset, you've caused massive environmental pollution. There's also nutrient pollution and a lack of above-ground biodiversity. So for me, as lots of people have talked about yesterday as well, the answer is ecological weed management. So ecology is the science, as Mary pointed out yesterday as well, of how organisms interact with each other and their environment. So ecological weed management is manipulating the interactions of those organisms, principally plants. So I view this as agroecology rather than organics. So my other term for this is plants versus weed, good plants versus bad plants. Grow plants under the vines that are going to keep out the weeds, the bad plants, while achieving your winemaking and vine growing goals. This also then provides all these other ecosystem services, the biocontrol, the pest control, biodiversity, nitrogen fixation, erosion control, and all the rest of it. Really easy for me to say as an academic pontificating from the stage. Actually trying to work out how you're going to do this in the vineyard is way, way, way harder. So, first things up, lots of experience from all kinds of systems, native plantings here in New Zealand. If you plant a woody species and if you don't keep it free of vegetation for the first few years of its life, it's really going to struggle or it'll just plain old die on you. So we need some way of doing that. We've got mechanical weeding. I've just given that a big old slag off. We've got mulches where you can use biological decomposing mulches or synthetic mulches. There's a bunch of pros and cons with those. And then we've got electrical weeding, which I've just shoehorned in here. So electrical weeding. If you're not familiar with this, it uses electricity to achieve a systemic weed kill, like glyphosate. That should be really pricking your ears up. I've been watching this stuff re-emerge over the last 8 years and kind of going, wow, that could be interesting, to this is interesting. This looks like it could actually be delivering the goods through to, I think we are now at the point, this is the real deal. It is still cutting edge technology and really expensive. But a lot of concern in this space around energy use. There's a lot of embodied energy in herbicides, and we spend a lot of energy forcing mechanical weeding tools through the ground. Electrical energy is lower than both. Sorry, electrical weeding is lower than both. And will the video work? Let's see if the IT guys are going to sweat themselves. So, this is an electrical weed from Zaso. This is clearly a promotional video. This vineyard does not need weeding. But just to give you an idea, you basically just take your existing mechanical weeder or sprayer off the tractor, put on an electrical weeder, and off you go. So I kind of go, well, we don't want to actually do this, but it's still a useful tool in the toolbox. We may have cover crops over winter under the vines we want to kill off. We can now do that without using chemistry or mechanical weeding. If we've got a living mulch and it's had its time and its time's up, we can terminate it with an electrical weeder and replace it with something that's better. So for me, these living mulches, this ecological weed control is the final destination. The challenge is finding out what's going to work. It's like that one block challenge. I've got a rule in this space: do not bet the vineyard on any ecological technique, because with ecology, everybody's mileage varies. It varies because this stuff's all sensitive to your soils, your climate, your grapes. Even within a vineyard block, what makes a good living mulch may vary. So, that one block challenge, I'd go even smaller to start with, a few meters of vineyard row, but replicate it across multiple blocks ideally, and go for lots of different stuff to start with. Try lots of different plant species, try monocultures and better mixtures, that diversity of living roots year round, in different blocks with different properties, different grapes, different soils. And if you've been running a cultivation or a herbicide system, your soil properties, your soil health will improve rapidly as you start putting living roots back into it. So your vines will respond differently over time. And survival of the fittest. If the grapes are going yellow, or worse, they're dropping their leaves, terminate what's ever underneath them. where they're looking nice and green and shiny, do more of it. Now, the problem in this space is we can't predict stuff. It's just too much complexity going on. We've got a few rules of thumb. These perennial living mulches are what we call in botany herbaceous species, i.e. they're pasture plants, grasses and legumes and stuff. So I've seen some bonkers stuff over the last couple of decades. You know, tiny little New Zealand native bitty-bitties. It's cool they're natives. They're absolutely shite competitors. You know, couldn't survive competition with anything. You spend their entire lives hand-weeding these damn things. So go for the cheap, common stuff. If you want to have high competition, go for stuff with lots of foliage. We're looking for thugs here. You know, red clover's my favorite in this space. Grasses typically have shallow fibrous root systems, which, as Bart's just been explaining, Krause has just been explaining, get right amongst those shallow feeder roots of vines. Now, Mary's been talking about grasses. There's a massive difference between those Australian native grasses and our highly bred, highly productive pasture species, pasture grasses. Our ryegrass is like Arnold Schwarzenegger to those Australian Pee Wee Herman native grasses. They are not the same thing by a country mile. Taprooted species are going to be in a different soil volume to those feeder roots, and particularly if they're legumes, which are going to be fixing nitrogen, which will be passed on to the vines, have the potential to increase vigor. And now we jump to nutrients. Nutrient loss at a global level, particularly nitrogen and phosphorus, are a bigger risk to humanity than climate change. Climate change is actually the fourth most important risk us humans face. And this includes New Zealand viticulture. And just because you are organic doesn't mean you will have lower nutrient losses. If you're doing a shed load of cultivation and shoving tons of compost around, your nutrient leaching profile will be the same or worse as conventional. So everybody can do better in this space. And I have to say, I don't just work in viticulture, I work across all the cropping species, annual and perennials. And I look at you guys and I go, that's really interesting. None of the nutrients you take off your vineyard at harvest end up in your final product. You know, it's not like potatoes or wheat or something like that, where hundreds or even tons of kilos of nutrients, NPK nutrients, leave the paddock. Nothing ends up in your final product. So where are your nutrients ending up? Well, obviously in your marc and your lees coming out of the winemaking process, which currently a whole load goes to landfill. And I kind of go, people should be locked up for sending this stuff to landfill, but hey, what do I know? So I look at this and go, well, the potential here is to have this kind of idealistic thing in organics of a closed nutrient cycle. All those nutrients that are left over from the winemaking process need to be returned to the vineyard from whence they came. And of course, with our history in organics, the first thing we go, oh, let's compost them. And I kind of go, yeah, that's really dumb. The thing with composting is 25 to 75% of the nitrogen in the starting material is lost during the composting process, mostly as ammonia, which fortunately isn't a greenhouse gas, but it's a really hideous environmental toxin. So there's nothing clever about that. And compost doesn't work well with all this high nitrogen sloppy stuff. So what we need is anaerobic digestion. Biodigestion, as it's also called. This is literally replicating what happens in the rumen of a cow or a sheep. Same biological process. It works better with these sloppy, watery, high nitrogen liquid materials, and we don't lose any nitrogen. These are sealed containers. Every atom of nitrogen that goes in ends up in the digest state that comes out, which is literally equivalent to cow slurry. And the methane, instead of burping it out like cows and sheep do, we trap it. We put a tap on our rumen. And we store that methane, and we can use it to generate electricity on demand to complement our solar panels and our battery systems to decarbonize our winery and our vineyard processes. Biodigestion also kills off a whole load of pathogens. And we can also store the biodigestate, including dewatering it. And then we can put it back on the vineyard at the timing so that when it releases its nutrients, the vines actually need it. I have to say, I look at all this mark going out on vineyards down the alleyways at this time of year and go, if you wanted to design a system to increase nutrient leaching in vineyards, I could think of anything better. So, I think we can actually close the nutrient cycles in viticulture, including nitrogen, which is the challenge for us in organics, because there are basically no cheap sources of bagged nitrogen. So we need to then import virtually no nutrients at all, which is going to help with our carbon accounting as well, and applied when the vines need it. So, we don't need to save the planet, we need to save ourselves from ourselves by stopping destroying our life support systems. The difference, the massive difference we had between organics and conventional back in the 80s and the 90s when I started out, in New Zealand in particular, is disappearing rapidly. So all of viticulture, organic and conventional, we have to reduce our planetary impacts if we are to stay alive. A key problem for me is that bare undervine. We've had lots of people bang on about that, so I hope the message has sunk in now. For me, living mulches are that destination for a whole host of reasons, and we can close those nutrient cycles at the same time. So thank you very much.